I'll bring my
No,
micrometer.
no one ever told you you can't say something you don't like it unless you try it. Yeah. Okay.
Okay. When are we trying?
Nope.
Your words, not mine. Yeah, Ron, tell him. You tell him. Eat his words.
Yeah, yeah, papa.
Okay, that's the connecting rod.
Yeah.
Yeah.
Hi.
Some of you guys are on there checking alignment, connecting rod alignment.
No.
So this is one view, and then you have this view, right? Okay, you're gonna check for two alignments. One, you're gonna check for bend. And bend is like this one. Bend this way, right? So in other words, yeah, that's bend. Okay, so that means this and this will converge at one point, right? The center lines will converge at one point. Okay, what's the other one? Twist. So it can twist and not bend, or it can do both. So that's the fixtures that we're doing out there on the granite table. The granite table, by the way, stays clear, even if it's on the cushion. Keep everything off of that. That thing is a granite table. That's like gold to a machine shop, because that thing does not flex. It is one piece, one solid.
Oh, the table in the corner?
Yeah, that's a granite. It's a granite table.
The table is pretty expensive.
So
For
is
a
that-
tiny one is $400.
Oh yeah.
So that's treated as a level surface, not to bag things on.
Not bad.
So you can lay up. You can put height gauges on there.
Yeah, no worries.
The machine shop, you have height gauges. You can do a layout, plus or minus a couple thousands. That's how good that table is.
Flat.
Yeah. So when you do it, you gotta make sure that your surface is clean. So put your hand on there and you can wipe. We have actually a fluid that wipes it down, granite white. But basically, you just want to get the dust off of it, so you don't put the metal down in between dust and you start to grind it in there, right? Anybody got granite countertops?
Yeah.
I do. They got sealer, they got polish, they got cleaner, all granite, special granite stuff. Okay, and part of the tools over there are two bars. These are called parallel bars. They're match set and they're ground. You can machine something on a mill or whatever, a blade machine, that can get you accuracy to a point. When they ground them or lap them, that's highly accurate. So those are a match set. You don't want to nick those either. So be careful back there. I'm gonna always take the group and set you guys up, help you guys out. I showed two groups so far. At least two groups have done it. So be careful with those tools. Those are good precision tools. Okay, so rod alignment. That's one thing you can do out there. If you want to clean the parting surfaces of your crankcase, use lacquer thinner. Ask Frank for lacquer thinner. Don't use MEK. MEK is curve your spine. I stay away from MEK as much as possible. Lacquer thinner is way more okay for body than MEK. MEK is really bad chemical. They don't even sell it at the hardware store anymore. They don't sell it down at Fiberglass Hawaii anymore either. They found it. They sell a derivative of it. The only place we got it now is from Goldwings. Big box, $40 a gallon. So we have a gallon here for when we get to composites and that kind of stuff, where the industry requires MEK. can't use anything black. Until they come up with a subsequent, use of another fluid. Okay? So gasket surfaces, oil, I'm working on getting some more solvent. So by the time it goes back together, we'll have a nice clean solvent tank, and we'll be able to clean everything before we put it back together. And typically what you do is you can put it under the solvent, get all the oil off, and then the best thing to do is stick it out in the sun, and that'll dry it off real quick. And then blow dry whatever's left over, the crevices. In the block, I'm just gonna say crankcase right here. At the very ends and some other passages, they have these little what they call oil gallery plugs. And they might have it all kinds of different ways. And what will happen is, when they machine the block, they drill a hole all the way through the block. And then maybe they'll drill another one down here this way. So that the oil flows within the crankcase to the various parts where it needs to go. You can only machine so many different ways, right? So if you do the machine hole, say the oil inlet was over here. But the machine hole goes all the way through. What they do is they put a plug over here. And depending on where it is, they'll put a plug. So it's called oil gallery plug. So by right, if you're doing an engine overhaul, you should take these plugs out so that you know that passageway is clear. You can get trapped carbon in here, especially where the oil doesn't flow. It may fill up the passage, but it may not flow. So the only way to truly clean it is to take the plugs out. But they're basically part of the case by now. They usually have to drill them out, so we're not going to deal with that part. But those little oil galleries, so you can actually see the oil gallery. When we get to lubrication, we'll talk more about them. Okay, so you can clean the crankcase. Clean the crankcase. Wipe it down now. You can go get some solvent out of the red solvent tank and wipe it down that way. Just enough to get it inspected. And if you really clean all the steel parts, it's gonna rust overnight. So you don't wanna have to oil it again and clean it again. Just wipe it down so you can do the inspection. If it takes a visual inspection, then that's another story. We gotta make our clean a little bit better. Okay, on your overhaul sheets, there is a, I'm trying to find it in there. There is a condition, right? It tells you, well, you gotta have a certain condition. And it's a visual condition. So in your textbook, on page 2-35,
Jepson?
Jepson, yeah, 235. I think I got the same textbook.
All for visual inspection.
See that word, see those words right there?
Yeah.
All those fancy words? They all mean something different. Those are the words you gotta use for your visual inspection.
Oh, yeah.
They should be in all the textbooks. They may not have the same listing exactly, but for the most part. So some of these are self-explanatory. Abrasion, Vernelling. Vernelling typically goes having to deal with bearings. And there's a lab project inspection of bearings. And we're going to use those terms. So you get comfortable with these terms, and you'll know what it is.
Oh, that's what that is.
Burning, burnishing is another one. Polishing, polishing of one surface, sliding with the contact with a smooth, harder surface. Okay. We're not gonna do too much burnishing, but Bernelling we're gonna be, in this class we'll talk about. Burr, chafing, chipping, corrosion, crack, cut, dent, erosion. Erosion is something you'll see inside the engine, especially in the combustion chamber. Flaking, fretting. Where are you gonna see fretting? Huh? Where would you see it?
Smoking rivets,
Oh, you guys talked about that?
dissimilar metals.
Okay, what about in the engine?
Similar metals.
Where are you gonna see, what is the definition of fretting?
Benches.
Surface.
Vibration. Like very.
Vibration.
Give me the conditions of the vibration.
Under pressure.
Under pressure. So in other words, two parts are clamped together.
Under pressure.
You think they're not gonna move, right? Wrong, they're gonna move. Sliding, the vibration. Where are you gonna see that on the engine?
Everywhere.
You might see that a little bit over here, but big time. The crankcase, especially the mid bearing, the mid saddle, in the middle of the block. The two ends not so bad, but that middle one, big time you can see it. So I want to point that out to you. That's ready. That's what eliminated most of those cases. You get that, that's it. The case is no good. The only way you can do it is you got to surface that entire mating surface, put it back together, and align bore it. Back to the standard. That's what they do. BWs can do that. But you gotta surface that whole thing so you make the cases match again. Because if I bolt one of those engines out there, I forget which one it was, we bolted together, torque it and everything, and you look down the side of the crankcase, you can see a gap in there. That's all bad. So that's spreading big time. Huh?
What is fire?
Maybe, maybe not. It's like I say, it's more pronounced on the inside of the engine than it is on the main surfaces, but you still get fretting. Galling,
Severe fretting.
yeah, that's galling, that's just general parts. Gouging, grooving, inclusion. Neck, peening, pitting, scoring, scratches, scuffing. What's scuffing? Scuffing is another one we use in internal combustion engine. Buildup or rolling of metal from one area to another, often caused by insufficient lubrication or clearance, or the presence of foreign material. Piston scuffing. Always see that piston scuffing. I got 2 pistons I'll bring in tomorrow from that I got severe piston scuffing. In other words, it's running on the cylinder surface. And for either there's no more oil or a whole bunch of stuff inside the oil, they got all black lines on the top. No good.
So is the piston softer than the cylinder wall?
So yeah, it's off the cylinder walls, yeah. So a typical place where you hear scuffing is piston scuffing, lack of lubrication. So a lot of these names will be more adhered to certain parts rather than just all general. Like Bernelling was, typically you see that on the bearings, scuffing you see that on piston. That doesn't mean it won't happen any other place though. Spalling, another one having to do with bearings. Bernelling and spalling is bearings. So when we do the bearing, all of this is take a whole bunch of bearings, we're gonna inspect them, and then we have a little oral on them. You're gonna tell me the names, you're gonna compare, and that's it. It's not a big deal, it's just to bring it out to you so you get familiar with it. But you guys gotta do it before you gotta be exposed to it before I come and say, okay, let's do an oral on it. I'll give you the right materials and the references. Okay, so the names, that's the visual inspection. And sometimes you gotta get that with your magnifying glass. Your 10 power magnifying glass should be in everybody should have one.
Yes, sir.
And if it doesn't say 10, guess what, it's not 10.
No. Wrong.
Might be 25, but I don't care, I know it's not 10. 10 power is standard magnifying glass. So if you're inspecting and you miss something and you didn't measure your 10 power, you're in violation. It's you. You overlooked it because your magnifying glass came from mom's drugs by power. Just saying. Okay, tables and fits and clearances. Just general, I'm not gonna go into any specific. Get familiar with the tables and fits and clearances and the pictures. We get to overhaul and 4-4, I'm gonna look at your numbers, or where you filled it in. I'm gonna see if they make sense. So if there's two different numbers and it tells you what's the clearance, that's the difference between the numbers. Or if it's a taper or out around. That's what I'm gonna cover. The last thing I'm gonna cover is out around versus run out. Don't get those two confused, they're two different things.
Are we allowed to use the limits here?
The what?
The numbers? Or are we always refer to the?
Refer to the manual, we got the correct one, right? So remember, we're gonna follow the overhaul manual, not the workbook. As far as the procedure, workbook's giving you a general procedure. You got the right engine, you got the right parts, you got the right manual. We use that. Okay, but when we get to 4-4, and I come down this spec, yeah, I'm gonna look at all your numbers, it makes sense. Oh, this is not wrong, you missed this, or you gotta fix this up. Hopefully I catch that before you make a final. And then I'm gonna say, oh, you guys ready? Okay, I'm gonna look at the picture, I'm gonna say, and I talked to this about a couple of students already. Number 505, what is that saying? The picture, on the picture, in the table of fits and clearances, that's pictures, right? With an arrow pointed to a line. So it's gonna say maybe piston in cylinder. That's what I want to hear. So you gotta be able to identify the parts. Piston in cylinder. Piston pin in piston pin bushing. Because there's a bushing there. Or rocker shaft in rocker shaft bushing. Not in cylinder head, but there's another one that has the bushing that goes into the cylinder head too, right? And that's a tight fit or a loose fit, where the bushing goes into the cylinder head. Loose. Tight fit, that's a press fit, right? The bushing is stuck in there.
Oh, I was thinking of the.
Okay, but the piston in the cylinder is a loose fit.
Because that has to be.
Are you talking about the bushing?
Either, it doesn't matter, bushing, whatever the bushing is in, there's an interference fit, they call that, right? Interference or press fit, you can say either one, I'll be all right with that.
Is there a bearing of bushing? Reading because they said like bushing is similar to a bearing.
Yeah. Which reminds me just now, I was going to tell you about the connecting rod. So I'm just going to draw one connecting rod.
Nobody seen that.
Okay, that's just the cap, that's all that's going to be necessary for this cap. Okay, you put the bearing shell in there. They call it a shell. Bearing half. By the way, what kind of bearing is that?
Wait, what?
Plain bearing. So there's a big surface, right? Surface area that the shaft will ride on. Whether it's for the connecting rod or the main, same thing, plain bearing. I'll talk more about bearings tomorrow. But this one, so if you put the bearing shell in, and you got the little notch, right, the little tang they call that. Okay, if you put it in, and you put your finger over this, you're gonna feel that the bearing is up a little higher of the surface of where it's being inserted to, whether it's the connecting rod or the cap. So they call this bearing crush, or they state, I think the book calls it a different one. I've always learned bearing crush. Doesn't really matter, it's the same thing. It's always a little bit taller, because what happens when you bolt it together?
It shrinks and then.
You squeeze it, just like you're pressing in a bearing, just like you're pressing in a bushing. So that makes that thing solid. It presses it in there by bolting it together. And that way that thing doesn't move. Right? It's like a press bearing, but it's halved. So they need that little bit, and it's usually about as far as I remember. Well, I'm not going to ask you that, but they might say that. How come the thing is? So that's bearing crush. Forgot what that textbook said. It's on the screen too. We'll look at it again today, tomorrow. Excuse me. A what? It's called a bushing would be same is considered a bearing. They call it a bushing because it's one piece and they press it in. It's just the language. But bushing is considered a bearing because it's going to be a rubbing surface, right? It's going to be another shaft or something that's going to be on there rubbing against it. So it's a bearing surface.
Compresses and then it expands.
Just like your shell bearings here, we're going to talk about the makeup of these bearings. That's another lab project when we talk about bearings. Inspecting plain bearings.
Kind of.
And what's all the other bearings grouped into? What other type of bearings?
Ball bearing.
No, ball bearing is one of them. There's more than just the ball bearing. What do they call all the rest of the bearings?
Roller bearing.
No, roller bearings is part of it too. It covers roller bearings, ball bearings, needle bearings. What do they call those? All grouped together. Yeah, bearings. No, that includes the plain bearings. Bearings is all bearing. That includes the bushings too, right? So we're going to separate the plain bearings from the ball, roller, needle. What do they call? This is going to carry on forever. This knowledge right here.
Straight.
Trying to see who read the book already. And one word.
Wait.
Anti? Anti?
Getting close. Anti what?
Friction.
Huh? Huh?
Anti-friction.
Anti-friction.
That's what I meant.
In the beginning,
All those other metal-to-metal bearings are called anti-friction bearings.
metal parts and stuff, I think.
Differentiated between plain
I think
bearings.
so. You see as the pages bearing.
Big name. That's a big. We're gonna talk about that till you get out of here, and then you're gonna see it all over the place. Anti-friction bearings.
So anti-friction bearings are the.
Ball bearings, roller bearings, tapered roller bearings, needle bearings, typically steel on steel. But there's exotic materials in there too, huh? Especially on the races. So we're gonna inspect those too. That's all in there because you got your thrust bearings, some of your thrust bearings are made out of ball bearings. So not always a plain bearing on an engine. Ceramic? Not that I know of.
Purple. Ceramic ball bearing.
Anti-friction, because this plain bearing's got a big surface that contact, right? Although when it's up to par, it's running on a film of oil. It's not even touching. When it starts to turn, that oil starts to go all the way around the surface, and you're actually running on a film of oil. It's not even touching the bearing. That's why it's so important to get oil pressure right off the bat. Because otherwise you will rub the bearing until the oil pressure starts to come up. and then your bearing is gonna start to deteriorate.
What says it reduces friction, so I'm assuming that means anti-friction.
We're gonna whole topic on oil too, so.
Yeah. It says reduces
Okay, last item.
friction.
Okay, the other thing we can do on the crankshaft, since you got the connecting rods off, and connecting rods off, and you take the crankshaft off, you do the measurements, right, your dimensional measurements. Okay, and I'll come and check you guys' work to make sure you get set up right. Then what are you gonna do with the crankshaft? Make sure it's not bent, right? What do they call that measurement? When you check to make sure it rotates straight. Run out. Not to be confused with out of round.
Yes,
Out of round, you measured 90 degrees. That's out of round.
round, circle.
That's not run out. Anything with the shaft, we'll go with crankshaft.
So the out of round, we just, look at the difference between the two measurements?
Yeah, the two different, that's a run, that's it. And also, okay, this is the journal, and maybe you did a measurement here on this journal. Okay, and then you did 90 degrees, right?
Right,
Out of round, you take the difference and you put that measurement down.
okay.
What about taper?
Up and down.
So you go from here and then you also do another measurement over here. That journal can actually taper. I've seen it. It might be only half a thousandth, you might not even find it, I don't know. But if you find something like that, depends on how accurate you are, right?
Would that usually happen if, like, say your rods are
Yeah.
twisted, because then you get a force on
It
one
could be
end
exactly
of the journal,
correct, yeah.
right?
What I used to see it was I putting automotive engines together. I think I put about 200 automotive engines together. And when the crankshaft came back from the crank grinder, I would always check. And I found out the guys was grinding the crankshaft at a taper. 1,000ths, that was plenty. So I told the boss, I said, hey, I'm not gonna put this thing together. He couldn't figure it out. So he went back to the crank grinder we had. Because we didn't, that's a $100,000 machine. So we couldn't afford that. So that was the only thing we sent out. So he gave him a chance, hey, you gotta check your machine. Something's wrong with your machine. Go check the measurements. This old guy down in Korea someplace. So I gave him a couple chances, came back and said, no, I'm not gonna put this together. Did you want to put my name on it? I said, no, my reputation's at stake. I'm not gonna put it together for you. I'm telling my boss that. So he went back, we found another crank grinder. These two big guys in San Island. And they had the name of their, something recent. Anyways, the thing came back, perfect. So you don't trust anybody out there. You're the last person to put something together. You make sure it's good. You're the judge. That's why you can have a welder weld anything. You're the guy gonna make the decision whether it goes on the airplane or not. Even if it's a certified welder, they don't need to be an A&P. You're the one making the decision whether it goes on the airplane or not. Same thing with machine. Anyways. My boss did that. My boss is a machinist, like I said, from Japan, right? So there was a couple of repairs on one of the engines. They had a repair scheme. I mean, it tells you exactly what to do. You can buy the parts and everything. Nobody in Hawaii liked do it. They were scared. So my boss went down and helped them out. He was in the machine shop. It was an aircraft, right? So they're like, they didn't get their name on it either. But they're the only ones on the island that had the machine to do it. Okay, I'm just gonna draw a shaft. It can be any shaft. In this case, it could be the cam shaft with the flanges out there like that, right? And then you have its journals, right?
Would that be a stain, Mr. Mike? That discoloration, would that be a stain or like some kind of rubbing?
Well, these are just, this is just the casting part of it. This is the journal. The bearing journal, right, of the camshaft. Can we erase this one? This would be the camshaft. I don't think that, normally you would do a camshaft, but in our case, we can do the crankshaft, that's what we have in those specs. Remember, we're not doing the whole engine, right? We're just getting something familiar with everything. Otherwise it'll be there forever. Okay, what you're gonna end up doing is you're gonna put this on V blocks. I don't know if I can write a V block correctly. V blocks. That's what they're called. So you're supporting the shaft in V blocks. And we have it underneath the sheet out there on the table. And there's bearings, ball bearings that are actually gonna be the V blocks. But I have a set of V blocks that are actually rubbed metal to metal. That's the most accurate ones. Okay, so you're gonna roll this. You're gonna roll this in the V block here, V block here. Okay, so how are you gonna tell if it's bent?
Look down the middle and then.
You can see it maybe, but we're gonna set up a dial indicator. And we're gonna put it down on this one right there.
Oh, yeah.
Okay, and it's gonna be on a stand too, so I'll set that up. Okay, and you gotta take that reading, and that's what your reading is gonna be if it's bent. You got a spec there. It can be a little bit out of, a little bit run out, but not that much. Okay, in this case, you have three bearing surfaces, so obviously you're gonna put the V blocks on either end. On the crankshaft, you get number 1, you get number 4. So the further out you go, the bigger the bend is gonna be if there's any bend at all in the middle. The closer you support it, the less of a reading you're gonna get. So there's more than one reading in your specs book. If it's supported at number 2 and number 4, it's a smaller reading than if it was supported on number 1 and number 4. So it'll be bent more, right? It's more. So in this case, we only got 3. Okay. I got a pretty good dial indicator to put on here. Okay, here's the clicker. In your table of fits and clears, you're gonna have a
Center.
what kind of a line is that?
Horizontal?
Center line, right? You get that from drawing, arrow 130.
Oh, yeah, okay.
Drawings will come back to haunt you.
Oh.
That's why I want you guys to get good at those mechanical drawings in that table of fits and clearances. You gotta be able to see those kind of things. Even if you never do engines, you're gonna see something else that's gonna be similar. Okay. So what you're gonna do is you're gonna rotate this shaft until you either got the highest or the lowest. Right?
Lowest.
You're gonna put the dial indicator on here, and you got a needle, right?
You gotta take both readings.
Okay? So you wanna find, you keep rolling the camshaft or the shaft around, it could be any shaft, till you find the highest part, and you'll see it on the dial, or the lowest, right?
So it's 4.
Okay, when you get to the lowest or the highest, you zero it out. And there's the glass case can move a little bit. Okay? So you zero it out, so you're starting from 0. And what you're gonna do is you're gonna turn this 1 revolution, 360 degrees only, that's it. So then it's gonna go to the opposite side, whether it's gonna be high or low, whichever you started with, right? You can set it at high or low. Say you set it at high. Okay, so this is the highest, and what I mean by highest is that this thing is bent like this, right?
Yeah.
So if it's bent high like that, that means it's gotta be bent low like this, right? The same amount. right? So now we're gonna turn it 180. And we see how much it goes.
The difference, yeah.
Should go down.
And then keep on going to 360, it should come back to 0, right?
Eventually, yeah.
So we take the reading at the 180?
You take the reading at the 180.
Okay.
And what do they call that? And I haven't been able to find it in the Lycoming book yet, but every place I know is the spec would be
Torsion.
total indicator reading. So 180, say it goes down 1,000, which is about right. Say it goes, the high side versus the low side is 180. I mean, it's thousandths out. Okay, so I gotta stop on 180, and my needle went to 1. 001. I'll probably say 1. So how far off the center line is it?
1,000?
Half 001. Half of it.
Oh.
Oh, because you're only turning 180. But there's one side that you're measuring one. Now you're taking the radius, but the first number is the diameter. Okay.
You guys get that?
Yeah.
So you gotta be careful of your spec. What they're giving you on the table of fits and clearances. Yeah.
So when we take our reading, it's the top one, but when we're looking at the fits and clearances, it's the bottom.
No, it should always be this. As far as I know, it's always, anytime I've done run out,
Yeah,
it's always been total indicator reading.
but as far as measurement, it's the
But
bottom
in
one.
reality,
Yeah.
it's only half of it off the center line.
I understand, okay.
You're measuring half here and a half there because but most times they're gonna say total indicator reading. It'll say that as a spec. I've seen that. I just don't know whether Lycoming wrote it. So that's something I'll be looking for. So we're gonna go with this, total reading,
Total reading.
for lack of anything better.
Okay.
So I'm gonna help you set this up, and then since I have all the tools out there, bring all the cranks out there, everybody's at about the same stage. Take the connecting rods off, and we'll set it up, we'll clean up the bearings, and once we get it cleaned up, then I'll bring out the tools, the dial indicator, which is a really good one, and we'll see.
That's for the catch up.
So
Any show.
hopefully I give you enough work for the rest of the day here. Okay, and then tomorrow we'll talk some more and then get, I gotta keep going, so then when we get to the overhaul, it's gonna be everything but what we've talked about. So that set of it will go faster. If we don't do this, we're gonna run out of time. Do it this way. Plus, there's nothing to do in the theory, and even construction, there's not really much to do. Look at the parts, get the names correct. Find out the construction features. We're gonna go deeper into that tomorrow. We did about half the lecture today.
It just carries over into the shop.
And it all carries over.
What about the construction test? Is that on Wednesday?
I'm gonna get that, I'm gonna put the calendar up. Hopefully this afternoon I can do put the calendar up. How many days did it say in the,
If I'm following it correctly,
4
it
days?
would be Wednesday.
47, so today's.
The 8th day would be the test, right?
today's 4,
Today's the 4th day.
5,
7 is
6, 7,
construction.
Wednesday should be the test, right?
Is the test.
So-
Quiz on Tuesday.
Got it.
Off Monday, yeah?
So we're all
Yeah,
from
we're all-
Monday.
Yeah, we're up on Monday, so one more.
So Friday.
Thursday.
Can we get the, you could just push it back.
Yeah.
Oh yeah, it's day by day, we still got 38 days to go anyway, right? Okay, but I wanted to get this, I needed to get this one, so there's no other way other than make a drawing to understand this. Alright.